Welcome to the Scientific American podcast for the 7 days starting March 1st. I'm Steve Mirsky. This week on the podcast, legendary astrophysicist Eugene Parker talks about a big problem with sending people to Mars. Geneticist Dave Coltman discusses the DNA analysis he did on a very unusual tissue sample. And geochemist Don Siegel feeds us the inside story on his new book. Plus, we'll test your knowledge of some recent science in the news. First up, University of Chicago Professor Emeritus Eugene Parker. Almost 50 years ago, he gave us a comprehensive explanation for the solar wind, the constant stream of charged particles coming at us from the sun. In the March issue of Scientific American, he explains that astronauts going on a trip to Mars have a bigger, tougher problem than the aliens or asteroids of science fiction. I called Parker at his home in Chicago. Dr. Parker, thanks for talking to me today.
Oh, you're quite welcome. My pleasure.
So you have this article in Scientific American in the March issue called Shielding Space Travelers, and it's kind of cold water in the face for sci-fi fans.
I'm afraid so. I was a little disappointed myself in where the facts lead you.
So the big problem, we're talking specifically about a trip between Earth and Mars, although this problem would come up in any kind of a trip outside the atmosphere, right?
That's right. A moon base, for instance, would have this problem.
Well, let's talk about the problem, because I haven't really explained that. The problem has to do with bombardment by cosmic rays.
Yeah.
What are cosmic rays, first of all, and why are they a problem for people?
Well, the cosmic rays are mostly protons, that is, the nucleus of a hydrogen atom, with the nuclei of a few nuclei of heavier atoms thrown in. They're moving nearly the speed of light, so that when they hit some matter, they go right on through, leaving behind a trail of atoms with electrons ripped off them and chemical bonds broken. Well, we're biological organisms made up of complicated molecules and chemistry, and this just does enough damage that it's unhealthy. If you get a very intense dose, you can be sick just from the fact that there's so much damage right at that moment. If you get a less intense dose, something spread out over more time, then it breaks a lot of DNA too, and even though you might not feel sick, the accumulation of broken DNA is not good. You tend to be prone to cancer in later years and so forth.
People on the surface of the Earth really don't have to worry about this too much, right?
That's correct. The atmosphere over your head is 14 pounds of air over every square inch, or a kilogram over every square centimeter, and that's enough to stop almost all of the cosmic rays.
In your Scientific American article in the March issue, you talk about the three most common proposals that people have put forth in an attempt to come up with solutions to this problem, and the three proposals to shield space travelers. And you pretty much take each one apart. Let's go through them. The first proposal that people put forth to protect travelers is to surround the ship, or to surround the individuals on the ship, with some kind of matter that will take the hits of the cosmic rays.
Yes.
So what's the problem with that one?
Well, the problem is very simple. It takes too much matter. You'd never get it off the ground. The best design that I know of was put together by some experts who were convened at Marshall Space Flight Center for a few days to sort of think it through. You want to use matter that has a lot of hydrogen in it, protons. That's the most efficient use of the matter. They suggested polyethylene because it's a solid. You don't have to build a tank to hold it. And the minimum weight was 400 tons. In principle, yeah, you could do it, but the cost just gets out of this world.
Literally. So the second proposal that people put forth is to put a magnetic field around the ship to deflect the positively charged ion. So what's the problem with that one?
Well, essentially you're imitating the Earth, but on a small scale. And because it is a small scale, you must use a very intense field. It's the product of the dimensions of the field times the strength of the field that gives you a measure of the deflection. And so you need something like 200,000 gauss. That's about 400,000 times more intense than the magnetic field of Earth. And it's clear you'd have to use a superconducting magnet. That is, a magnet in which the current-carrying wires were superconductors. And Professor Sam Ting at MIT got his group together. They've had a lot of experience with superconducting magnets in high-energy physics experiments, so the technology is pretty well known. And they came up with a design which would go for 9 tons. And again, you can lift this off the surface of Earth, but putting it down on Mars and bringing it back again, it gets to be difficult, and that is to say, expensive.
Right.
And then there's the problem, too. The effects of strong magnetic fields on a person living within the field are not known.
So we might be replacing one health problem with another health problem.
You might, yes.
So the third proposal is give the entire spacecraft a positive charge to repel the positively charged ions coming at it. And what's the problem with that?
What people forget is that space is not empty. Space at the orbit of Earth has about 5 electrons and 5 protons per cubic centimeter. Those electrons would just love to see 2 billion volts positive. They would come ramming in like cosmic rays.
Maybe there are biological solutions that we don't know about yet, where potential space travelers could take some kind of a treatment in advance that would stop the damage from happening. Or maybe you'll just find people who are willing to do it anyway.
The data that are used to proclaim what is safe and what is not safe come from people who have accidentally received a burst of radiation in a laboratory accident, or have been subject in Japan to a nuclear bomb, and they got a big dose over a very short period of time. And the assumption is that it's the total dose that counts. Now, that might not be true. It might be that if you got a low level, such as you would from cosmic rays, spread out over a couple of years, that your body could repair some of that damage over the period of time, and you would not suffer so much as if you had gotten the whole thing in a relatively short period of time.
Mm-hmm.
That is conjecture. Nobody knows to what extent that would improve the situation.
Well, Dr. Parker, it's been a pleasure to talk to you. The news isn't good, but it's good to talk to you anyway.
Well, it's nice to talk to you, and I hope the future brings more hope.
There's a lot more on this subject in Eugene Parker's article called Shielding Space Travelers. It's in the March issue of Scientific American, available for purchase at newsstands and at our website, www.sciam.com, www.sciam.com. Now it's time to play Totally Bogus. Here are 4 science stories. 3 are true. See if you can figure out which one is totally bogus. Story 1. The ivory-billed woodpecker was thought to be extinct, but last spring, ornithologists reported that they found one of the birds living in Arkansas. Now a research team reports that over 100 of the woodpeckers have been quietly living on the private Arkansas estate of the Walton family, the owners of the Walmart store chain. Story 2 is from the Behavioral Psychology Files. A group in New Zealand was upset about the content of an episode of South Park that was scheduled to run in February. Doesn't matter what group, all outraged groups pretty much make this same mistake. They mount a publicity campaign to urge people not to watch the show, and so when the South Park episode ran in New Zealand, it drew 6 times its normal audience. Story 3. Researchers found that their quantum computer gave them meaningful data by not running the program. And Story 4, the Discovery Health Channel is running this double feature in March, Half-Ton Man, followed by 750-Pound Man. We'll be back with the answer, but first, call it CSI Sasquatchawan. Well, close. Dave Coltman is a geneticist at the University of Alberta. He heard about a Sasquatch sighting in the Yukon that included the recovery of some alleged actual Sasquatch hair. So Coltman put his big foot down and offered to analyze the DNA. If you've yet to hear about the results of that test, here's what Coltman said when I called him at his office in Alberta. Professor Coltman, thanks for talking to me today.
No problem.
Tell me about how you wound up doing a DNA sequence analysis of what was allegedly a Sasquatch.
Well, it was last summer in July, and I was watching the news, and there was a Sasquatch sighting in the Yukon that had really sort of taken the imagination of the media. So it was on the CBC, it was on television. And these people who had seen this Sasquatch in their backyard had actually found hair and footprints the next morning. And they sent the hair to the regional biologist in Yukon, who I happen to know. I've done some work with biologists in Yukon before. And I think one of the media asked them if they would be able to do a DNA test. So they didn't have the resources to do that. So that evening, I on a whim almost, sent him an email and said, just send that hair down to our lab here and we'll test it for you, because we do a lot of DNA work from hair and other kinds of samples. So it was quite a straightforward thing for us to test. And I thought, well, kind of on a whim, and also maybe to help him out so that he could be absolutely certain about what it was, and to satisfy the curiosity of the public, that we would run this test for him.
So this was more of an exclusionary test.
Well,
you didn't think it was going to be a Sasquatch.
Well, we were 99.9% sure, but there's always a shadow of doubt.
Right, because being a good scientist, you left open the possibility that it was a Sasquatch.
Well, of course, you have to do that. You can't. We never accept anything as being absolutely true. I mean, we work in the other direction, which is we try to rule out the things that we can disprove. What I was really thinking about was, this is a good story to tell high school students to get them interested in DNA profiling, and the fact that there's CSIs on television, but in fact we do stuff like this pretty routinely all the time. So that was one of my motivations.
So you get the sample.
We get the sample, and my technician handled it, Dr. Corey Davis, and he extracted DNA from the follicles at the root of the hair. There's quite a large sample, quite a large clump of brown woolly hair. So it should have been a good source for DNA, because you need the follicle. It's usually where you get the best DNA from. And he extracted DNA and amplified a gene fragment from the mitochondria, and then determined its DNA sequence.
And the sequence analysis showed you what? Well,
what we do is, if we have a sequence from an organism, and it's the first time we've seen it before, or if it's an organism let's say if it's an organism we didn't know, what we do is we align this sequence to all of the known sequences in the international DNA databases. So everybody who's sequencing DNA for any reason usually submits their sequence to this central holding facility, if you like, called GeneBank. So we tested it against that database to find out what it would match. And this is something you quite literally cut and paste the sequence into your browser on the web, and it'll return the best matches. And it came back with 100% matches to a bison. So we were pretty sure we had a bison.
Well, how disappointing.
Yes, it was. But in hindsight, I mean, I think we were actually quite relieved that we got a DNA sequence from this hair at all. It was really tough to get DNA out of this specimen, which in itself tells us something. See, normally if we pick up a hair, like with a snagged on a tree in the field or anywhere, and it has a visible follicle, it's very easy to get a DNA profile from that. We never have any trouble. But in this case, Corey had to try over and over again and every trick in the book to finally he got a DNA profile from it. So there was something suspicious about this hair. Either it had been outside for a long time, or maybe it had come from a rug or a coat and it had been tanned, because that destroys DNA.
Aha. So you suspect that someone might have been running around the forest wearing a bison skin rug and masquerading as a Sasquatch?
That's indeed one possibility. Or it blew there on the wind, or, a bison went through their backyard.
If there was a real Sasquatch out there, what would you expect its DNA sequence to most closely match? Right.
Well, I think conventional wisdom, if you like, has it that Sasquatch is probably a primate. So in which case, I think we would find a very high similarity between that sequence and probably human or any other hominoid primates that walk upright. So my guess is that we would find a close match to primates, and particularly a close match to human, but not 100% match.
Well, thank you very much, Professor Coltman.
You're welcome.
Professor Coltman's paper appeared in the February issue of Trends in Ecology and Evolution. The title is Molecular Cryptozoology Meets the Sasquatch, and it's available online. The website address is nasty, so just Google Coltman, Coltman, and the word trends, and it comes up in the first page of results that you'll get. Now it's time to find out which story was totally bogus. Let's review the 4 stories, 3 of which are real. Story 1, ivory-bill woodpeckers have been living with the Waltons. Story 2, urging New Zealanders not to watch South Park had the opposite effect. Story 3, a quantum computer works by not running. And Story 4, a Discovery Health Channel double feature is Half-Ton Man followed by 750-pound man. May I have the envelope, please? The usual audience for South Park in New Zealand is about 32,000 people. After being urged not to watch, 210,000 people tuned in.
Wow, what a terrific audience.
Yes, the weird world of quantum mechanics means that the computer gives a meaningful answer even when you don't run the program. And Schrodinger's cat is sleeping on top of the CPU. Or not sleeping. Anyway, you can get the details in the February 23rd issue of the journal Nature.
I am the Osimo 4000.
The Discovery Health Channel is running the 1,750-pound double feature on March 5th, according to their website. But listen, you don't lead with the half-ton man and then follow up with the 750-pound man. You wouldn't start a sci-fi double feature with The Thing and then follow it with the somewhat smaller Thing.
I learned something today.
Which means that the story about the ivory-bill woodpeckers is totally bogus. Which is just as well because nobody needs a big sale on ivory bills at Walmart.
Attention, shoppers.
Next up, Syracuse University geochemist and hydrogeologist Don Siegel. He has a new book out, and though it is technically about chemistry, you'll have to use your noodle to see the connection. I called Siegel at his office in Syracuse, New York. Professor Siegel, good to talk to you today.
Yeah, good morning to you.
Tell me about your work in general, what you study, and I know that you recently won the Meinzer Award, a very prestigious award in your field. What was that for?
Yes, I'm a hydrogeologist and a geochemist. I study the fate and transport of contaminants in groundwater. I study water resources, and I study issues related to global change. So recently I was delighted to have won the Meinzer Award from the Geological Society of America. And this is an award given for making fundamental discoveries in hydrogeology. So my colleagues decided that a number of papers I wrote 20 years ago have made impact. It takes a while sometimes. And these papers related to how glaciers 10,000 years ago pumped fresh water into otherwise dirty aquifers, hence, in a sense, cleaning them up. So now we have potable water. And so a couple other papers related to how methane gas is generated in peatlands and how peatlands growth is related to groundwater hydrology.
That sounds like very interesting work and very topical. But you're also the author of a new book.
Yes, I'm an author of a kosher Chinese cookbook.
And it's called? It's
called From Luxian to Lo Mein. Luxian is the Yiddish word for egg noodles. And lo mein, of course, is a Chinese noodle.
So the question then is, what's a nice Jewish geochemist like you doing writing a book on Chinese cooking?
Well, I've always had a passion for cooking in general, and during the past 15 years or so, I've been catering very large Chinese banquets for Jewish fundraising organizations here in upstate New York. And there's always been a connection between Jews and Chinese food. A lot of people realize that on Christmas, many Chinese restaurants stay open in order to serve their Jewish clientele.
On the back of your book, there's a quote from a Professor Chen Zhu, who is a colleague of yours.
Yes.
And he says he proves, he being you, he proves my longtime belief that a good geochemist must be a good cook first. Is that true?
Oh, I think so. Many of my geochemist friends are good cooks, and the process is pretty similar. If you're a chemist, you go in the lab and you mix reagents, and then you get reactions going and products coming out of your reactions. In cooking, it's the same kind of thing, where you mix all these ingredients, watch reactions proceed, and then a product comes out. The only difference is that in my geochemistry, it takes 6 months to years before I figure out if I'm right or wrong. But when I do my chemistry in the kitchen, I determine if I'm right fairly quickly.
Right, the taste test.
The taste test, that's right.
It must be nice to have some more instant gratification for a change.
I'm really big on instant gratification.
And it's tough to get that doing scientific research often. So
that's right. It took me 20 years, right, to get the award.
Right. There's a very a cute story in the book. I should say that about the first 35 pages of the book are a narrative, and then you have a lot of recipes.
Right.
And there's a cute story in the book about another colleague of yours who got married. You want to tell that story?
Yes, there was a colleague of mine here at Syracuse University, Wu-Tae Chen, and Wu-Tae married a Jewish woman, Marjorie Baruch, from the famous financier family. She's a friend of our family's. And so Wu-Tae converted to Judaism, and then when he was introduced to his to Marjorie's family, he met one of the great aunts, one of the big people in her family. And so the great aunt looked him up and down and said, "Well, you must like Chinese food." And then Wu-Tae responded immediately saying, "But of course, I'm Jewish."
That's great. That's a great story. You're going to be out on tour with your book?
Yes, I've been on tour. I've gone from L.A. to New York and from Detroit to San Antonio, doing food shows and book signings and discussions. And I'll be in Scotch Plains, New Jersey, on March 9th.
And how can people find out about that appearance?
They can find out the details from my website if they want. It's www.kosherchinesecooking.com.
Great to talk to you today. Thanks very much.
Nice talking to you, Steve.
Well, that's it for this edition of the Scientific American Podcast. Our email address is podcast@sciam.com. That's podcast@sciam.com. And also remember that Science News is updated daily on the Scientific American website, www.sciam.com, www.sciam.com. I'm Steve Mirsky. Thanks for clicking on us.
That's all, folks. That's all, folks. That's all, folks.